The next part is the role of abiotic parameters on marine life. The ecology of seas depends on the biotic and abiotic physical and chemical parameters. Nature of seawater, properties of seawater, interaction of seawater with atmosphere, solar radiation and density differences, wind driven forces and hydrostatic pressures are the abiotic aspects controlling the oceanic marine environment. The significant roles played by the following parameters are to be understood in biological oceanography also: solar radiation, temperature, salinity, density, pressure and surface currents. Sunlight is the most important parameter for many marine life in the sea. Only a fraction of sunlight can penetrate through the surface zone and help in carrying out the photosynthesis. The energy is consumed for the conservation of inorganic matter to organic compounds. The depth-wise distribution of plants and animals is also controlled by the light. There is also a periodic change in the solar radiation and light penetration. These help the vision in animals and their migration and breeding periods within the sea. About half of the solar energy is absorbed or scattered by various layers of the atmosphere. Only 50% of it is reaching the sea surface. In this, some portion is reflected back to the atmosphere depending upon the angle of incidence. The amount of radiant energy reaching the surface is a function of the sun angle, the length of the day, the time of the day, the time of the year, the latitude and the prevailing weather conditions. The temporal variations of radiation may be diel variation, diurnal variation and seasonal variation. The properties of water are very unique when compared to other liquids. Water is normally transparent to solar radiation. About 50% of light which penetrates the sea surface is found to be having the wavelength longer than 780 nanometers. This part is the IR radiation, which is absorbed and converted into heat in the upper surface of the oceans. The visible portion between 400 and 700 nanometers penetrates further below the sea and helps many life to survive. This portion is known as photosynthetically active radiation (PAR), as it helps phytoplanktons to carry out photosynthesis. The extinction coefficient depends on the amount of colored dissolved organic substances present in seawater and also the chlorophyll pigments of phytoplanktons. Based on the light intensity and relative penetration of light in the sea, 3 vertical ecological zones have been identified. They are the euphotic zone, dysphotic zone and aphotic zone. The shallowest zone is the euphotic zone just below the sea surface. Light penetration fully supports all phytoplanktons to grow and reproduce. The respiration loss is also balanced by a compensation depth, which is the lower boundary of the euphotic zone. The dimly lighted zone below the euphotic layer is the dysphotic zone. The last layer, which is under complete darkness where sunlight cannot reach, is the aphotic zone. Many marine processes are controlled by the temperature of water. Oceans are cooled by evaporation. A good amount of heat is transferred during this transformation of water into water vapor. Ocean surface temperature fluctuates with reference to days, months, seasons and years. It also varies with reference to polar, tropical, subtropical and temperate zones of the globe. The surface turbulent waters also transfer heat downwards. Due to this, the uppermost part of oceanic water has a relatively raised temperature. This gets decreased at a depth of about 200 to 300 meters and it goes up to 1000 meters. The water layer showing the steepest temperature gradient is known as thermocline. The zone showing the rapid changes in the density of water is known as pycnocline. Pycnocline acts as a barrier to vertical water circulations and also animal movement. At a depth of 2000 to 3000 meters, The oceanic water temperature never rises above 4 degrees centigrade. It also goes up to 0 degrees to 3 degrees centigrade in deeper parts of the ocean. Sea water is a unique water. It contains more dissolved salts than river water, lake water and rain waters. The salinity is referred in terms of total dissolved ions and other compounds and gases. The average salinity of oceans is 35. Vertical variation of salinity is an important limiting factor for marine life. The layer at which a rapid change in salinity occurs is known as halocline. Salinity varies with reference to seasons and locations. Marine life has unique physiological mechanisms to cope up with the salinity. Osmoregulation is one of the essential mechanisms. Marine life is also classified based on their tolerance level of salinity. The species which can tolerate a wide range of salinity are called as euryhaline species, and those which can tolerate a narrow range of salinity are called as stenohaline species. Hydrostatic pressure of oceanic water is determined by the equation rho GH, where g is the acceleration due to gravity, rho is the density of water and h is the thickness of water column. Pressure increases due to the weight of overlying mass. Marine life existing in the deep oceans are subjected to very high pressures. The pressures may go up to 1000 atom in deep ocean basins. Some animals travel up and down for several hundred meters and experience this change. Both pelagic and benthic species do inhabit these changes. They are called as eurybathic species. The marine life which cannot tolerate such pressure variations are called as stenobathic species. Ocean water surface currents are generated by winds. These water movements influence biological productivity and nutrient availability. Due to this, the geographical distribution of pelagic and benthic marine species are also varied. Ocean surface currents are fully controlled by the global wind systems. Their directions are modified by the Earth's rotation also.